Hi everyone, welcome to this talk and thanks for tuning in. My name is Segun Famisa and I'm an Android engineer at SoundCloud and also a Google developer expert for Android. I'm based in Germany and I moved here 3 years ago. Today I'll be talking to us about the new kid on the block when it comes to building UIs, Jetpack Compose. I'm pretty sure many of us might have heard about this, especially if you're Android developers. In this talk, we'll cover some basics of what exactly Jetpack Compose is, in case you're not already familiar with it. We will talk about the problems that it's here to solve, like why do we even need Jetpack Compose in the first place? And this one is a buzzword that I'm sure many of us might have heard recently, the declarative UI. We're going to talk about what exactly that means. We will also touch base on how Jetpack Compose works, the current state of Jetpack Compose, and how to prepare your apps for adopting or migrating to Jetpack Compose. We'll also have like a futuristic idea of what's coming next in this new paradigm of the declarative UIs and Jetpack Compose. So what exactly is Jetpack Compose? According to the official definition, Jetpack Compose is Android's modern toolkit for building native UI. In simpler terms, I'll say Jetpack Compose is just the latest open source technology that is used to build Android UIs. It's a declarative UI toolkit and it has a reactive twist to it and makes use of a runtime and a Kotlin compiler plugin. Jetpack Compose is not alone in this new category of UI toolkits. In fact, it's likened to look a lot like Flutter, which is a framework for building cross-platform applications primarily on Android and iOS, but also it works for the web. Swift UI also is a framework for building UIs on iOS, and React Native is another cross-platform framework for building applications on Android and iOS, and even the web. So let's quickly go over some reasons why Jetpack Compose exists in the first place and why we should care about it. Jetpack Compose is written in and with Kotlin. So the possibility of writing your UI in the same language as the rest of your app is a very, very huge advantage. First, it allows more people to be able to contribute to your code base. Imagine you have a team of backend Kotlin engineers and Android engineers. The fact that the Android UI can be written in plain Kotlin allows easier transition of engineers from non-Android stacks, maybe from like the backend team, and allows them to easily integrate and work on the Android code base as well. Another interesting point about this, the fact that it's in Kotlin, is that Jetpack Compose makes use of the idiomatic nature of Kotlin programming language. I don't know if you already use Kotlin, but Kotlin is a very, very idiomatic language. It helps you write a lot of code in a very short and concise and very readable format, and Jetpack Compose takes advantage of certain features in the programming language, including like lambdas or like higher order functions and things like that. The toolkit also takes a full advantage of the extensions that the language offers in terms of being able to extend the language by writing a compiler plugin or writing custom annotations to modify the code that is almost synonymous, that is almost like operating at the same level as language features in itself. Jetpack Compose changes our mindset when it comes to building UI. It helps to have better code by changing how we think of UI code. In Compose, for example, we think of UI as a combination or composition of small units of UI elements that are fused together to form the larger UI. In the example on the screen now, we have like a screen, it's like the parent widget, we have the news feed, then we have the story widget. So Jetpack Compose helps us break down the thinking of how we look at these UIs, and then from there, it helps us to rebuild it from ground up. Jetpack Compose, like I said, takes advantage of the conciseness of Kotlin. The toolkit also takes advantage of the extensions the language offers. like I said the other time. So unlike the traditional view system, Jetpack Compose does not require us declaring UIs in XML. And in fact, that makes it shorter to write UI code with Jetpack Compose. Let's look at an example. Let's say we want to implement the simple list UI on the screen. To do this currently in Android, we have to create at least 3 classes and 1 layout file. Depending on the nature of your app, you might even have to create more. You need to create an adapter, you need to create an item class, which is going to contain the UI representation of your item. And in this case, it's going to contain the title, the news source, the date, and whether it's bookmarked, saved or not. In addition to that, you need to create the XML layout. And in fact, this XML layout could be simple, it could be one file, or even multiple files, depending on how fine you separate your concerns. That's 4 files just to create this list. In Jetpack Compose, on the other hand, you need only 1 class to implement this. Of course, you may have more depending on how much you decide to separate your concerns, but overall, you're going to have less lines of code to implement this in Compose than you would have needed to implement in View system. So Jetpack Compose really shrinks the size of our code, and this is possible thanks to the Kotlin programming language. Another really interesting part about Jetpack Compose is that unlike the traditional View system, Jetpack Compose is decoupled from the Android framework. Now, what this means is that usually when we get new APIs in the Android SDK, we have to add logic, things like, oh, if you're running on Lollipop, don't use this. Use the app compat version if you're running below Lollipop, and things like that. With Jetpack Compose, since it's not related to the Android framework, between an update, you don't need to wait for new updates of the operating system before you implement some features. Just updating the library helps you get a lot of features. And it means that you can use the Compose APIs irrespective of the API levels that your app is targeting. And that makes life really easy for developers while delivering premium experience to the users. In fact, this feature is what makes it possible to extend Jetpack Compose for other non-Android platforms. We'll actually talk about this a little later on. Jetpack Compose is interoperable with the traditional Android view system, and this is one of my favorite parts again of Jetpack Compose. On top of all of the nice features we have, it is interoperable with the traditional view system. What this means is that it allows us to go through incremental migration towards Jetpack Compose. In effect, it means that you can call the view system from Compose or call Compose from the view system. This flexibility is really helpful when migrating. Let's have a look at some examples. So to use Compose with the view system, the library comes with something called a Compose view. Say for example, you want to migrate your UI, but you want to start, for example, let's say from a fragment or an activity. This Compose view is what does the backporting for us. The first step would be defining this view in the rest of your XML layout. Then after you declare this view, then we do it like we normally handle the rest of the views. We find the view, just like we would normally do, and then we invoke the set content function. Now that set content function is what takes us from the view system to the Compose system. And then within that set content function, we can put our composable functions, and it's going to go down from there as if we were writing the regular Compose app. In this code sample, you'll notice that I'm in a fragment, but the same applies if we were in an adapter or in a custom view or in an activity. On the other hand, it is possible to use the view system from within Compose. So you may be wondering, why do we even need to do this in the first place? So it is possible that you find yourself in situations where you're working with views that are not yet in Compose, either because you have not migrated them yet or because it's a third-party view that doesn't have a Compose equivalent. For example, let's say you have an app that uses the map view. The map is what we use to render maps in Android. And as at the moment, this view is not yet available in Jetpack Compose. So you're wondering, so how do we use this? There are two ways to do this. First option is to use this Android view component that I'm talking about. It's like in the code. The Android view component takes in the view, which you can create right there using the context through the constructor of the normal view class in the view system. It's important to know that this creation happens only once and is guaranteed to be called on the main thread. Because of the constraints of the Android system, we don't want to create a UI. Only the thread that creates a component can modify it, and as a result, we don't want to create views in the background thread. So Compose guarantees that this create function will be called on the main thread, and it's called exactly once. The component also takes in a lambda expression at the back as the last parameter, and this function helps us to update. So every time when Compose needs to redraw or re-update this screen, this is the function that is called. So the function might be called a lot of times, depending on as many times as we need to update the hierarchy or re-render the UI. Another way to do this is to use the Android view binding API. This API comes as part of a UI view binding library that is part of Jetpack Compose suite. Here, all we need to do is pass the result of the inflate function, and the system Jetpack Compose handles how we create it, and this is analogous to the create function in the slide before. Just like the previous method, the update function could be called multiple times, but the create function is called just once. So with these two approaches, it is possible to use the view system with the Compose system. And this is a really important part of Jetpack Compose, the ability to use, to interoperate traditional view system with Jetpack Compose system. So you must have heard about declarative programming, imperative programming, and all these terms. They are buzzwords, but they are really important today. Let's talk about imperative programming. Generally speaking, imperative programming is a style of programming that many people are used to. It's the style where we write code by writing how things should be done in the steps that are required. It's almost like you're building blocks of instructions. Declarative programming, on the other hand, specify what needs to be done and not necessarily how it's done. Let's have a look at an example. So in the block of code we're about to explore, we're trying to set up a button. What stands out here is that the piece of code describes how to set up that button. It starts by finding the button with our normal view, find view by ID call, and then it sets the text, and then sets the text color, and then here we have a condition. When the count is more than 0, we make the button visible. Otherwise, we hide it. This pattern that you look at here, this step-by-step, block-by-block pattern is what is called imperative programming. You will see how it varies, how it's different from declarative programming. Declarative code, on the other hand, tells us what we need to do. In this code snippet that we're looking at, we only know that when the count is greater than 0, we create a button with the text click me and the color red. So this exactly tells us what we want to do. How it's going to be done is left to the framework to figure out for us, and this is why this approach is great. It hides a lot of information, it abstracts a lot of information from us developers who are the users of these APIs, and it puts it, and the responsibility goes on the system to render it how it does it best. So let's look at some differences between imperative and declarative programming in order to fully understand how these two paradigms differ. In imperative style, we had to manually construct step by step and mutate all of the changes we wanted to put on the button. First, we had to find the button, then we had to set the text, then we had to set the text color, and then we had to hide it if the count is less than 0 or equal to 0, and then we show it when count is greater than 0. So this is a typical example of how we build UIs currently. The major drawback here is that it's easy to end up in a weird state. Let's say we forget to write tests or we forget to add some code there, and then we end up in a state where when count is greater than 0, we still don't show the button because we're dependent on a lot of logic there. In the declarative style, however, we didn't have to construct the UI from ground up. In fact, we only specified, we specifically described how we want the UI to look. We want the button to have this text and this color, and when the count is 0, and that was all. So you see that the UI is redrawn and updated based on the current state. So the code we write describes the current state that we have. And that's how this is majorly different from imperative programming, where we had to list the steps to achieve that state. In declarative programming, we just tell it the state we want to be in. You might notice this style is recurrent if you've done some Swift UI or you've done some Flutter or you've done some React Native. It is still basically the same technique that is borrowed all around. So how does Jetpack Compose work? There's a whole technical talk from Leland Richardson, who is one of the developers working on Jetpack Compose at Google. The talk is about how Compose works under the hood. It covers a lot of technical detail, including the underlying data structure, what makes it efficient, gap buffers, and the techniques that the system uses in composing and recomposing the views. So I don't think it's necessary for me to go over that again, because I'll basically be repeating what he has said. And you should totally check out this talk and many more talks that he has given on the same topic. So where are we today with Jetpack Compose? How ready is it? What resources are out there? Is it ready to be used for us? First of all, I would say it's not ready. I mean, it's kind of ready, but not really ready for production use. It's ready for you to use in your playground apps, in your sample apps, but it's not really advisable for production use because Jetpack Compose is currently in alpha. And what that means is that it's very possible for the API surface to change from time to time. As at the time of this talk, the latest version is alpha 07, which means it's just the 7th alpha, and I think it's too early to adopt in your production apps. Jetpack Compose has been available openly since developer preview, and another interesting thing about it is that it was built entirely in the open. The team have been consistently looking for feedback. It's been developed in the open. The discussions happen live on Kotlin Lang Slack channel. So I really appreciate this method of developing a software toolkit that everyone is going to use, so everyone had a say in how it was being built. Jetpack Compose right now has a lot of support from Android Studio. I recommend using Android Studio Canary from 4.2. The Canary versions always get the updates from Google even before it makes it into beta or the stable version. So it's usually recommended to use Canary for state-of-the-art things like Jetpack Compose. There are different ways the Android Studio supports it. My favorite one is the preview tool, but there's also the lint rules, there's a great autocomplete, and the bundling of the sources. Like I said, my favorite part there is the preview tool. So if you look at this snippet on the left side of this screenshot, all I did was annotate the function, the composable function with preview, and it showed up in the right hand side. There are even more advanced uses of this annotation. There are some uses of it that allow you to specify the data, the test data that is being used to render the preview. It also has an interactive mode where it is possible to interact with the preview. There is also the possibility to deploy the preview onto a device or an emulator, and this really shortens the development lifecycle and the feedback. Unlike normal view system where you have to build the entire app and you deploy on the app and you have to navigate to the screen you're currently developing, Jetpack Compose makes it all easier by even making it possible to just quickly deploy the preview. So Jetpack Compose already encourages the fact that you need to just think modular. You want to see how your list item looks on the device, run the sample preview. You want to see how the whole screen looks, but with fake data, run the preview on the device. And this mindset is what I really like about Jetpack Compose. Another thing that is worth noting about Jetpack Compose is that it incorporates nearly all of, if not all, of the principles of material designs from the ground up. These principles cover like typography, color, shaping, theming, and all that stuff that you do with material design. Unlike in the view system, like in our current state, where it kind of feels like material design was an afterthought, with Jetpack Compose, everything feels natural and part of the framework from the ground up. Let's look at how material design theming happens in Jetpack Compose. So we define a composable called say theme. It even has like the dark theme or night or light theme, such that you can even choose the colors to use, the typography to use, the shapes to use. All of the principles from material designs are like almost built into the material design library of Jetpack Compose, and that's really impressive and that's really interesting for me. So whenever you're building your app, you could already build in the design system into it. And it's also flexible such that you can modify the material design to fit your own current design system in your app. So we have looked at a lot of nice features of Jetpack Compose, and now we're wondering how to get our app ready for Jetpack Compose. What do we need to do? How much work is it going to be? When is it going to be ready? I just want to say again that it's too early to adopt Jetpack Compose in your production apps because the API surfaces are probably going to change a lot and there might be some bugs here and there. But you can definitely use it in your sample apps or prepare your apps for migration. Even though you're not using Jetpack Compose yet, there are a couple of things that you need to have in mind so that you're ready for Jetpack Compose when it finally comes. It's very difficult to make huge changes to software. For example, I don't know how feasible it is, but I don't think it's very feasible to pause all of your future development work in order to adopt Compose. So my suggestion here is to build things iteratively. You have to start with building blocks from one widget to the next, and you have to gradually build up your migration from traditional view system to Compose. Compose has a lot of features that makes this really feasible and practical, so you should totally be able to build iteratively. In my opinion, implementing uni-directional flow of data is one of the most important things that you can do to get yourself ready for Jetpack Compose. In fact, I think it's going to be a required step for you to fully take advantage of Jetpack Compose the way it was designed or the way Google had it in mind. In case you don't already know what this means, let's talk about it very briefly. So like I said, in order to get your app ready for Compose, you have to get your architecture right. Compose is specifically designed to be used with any architecture that ensures unidirectional flow of data. This is very essential because in the Compose mental model, the events are received from the UI and passed to change the state, and then the state is passed all the way down again from the parent component all the way down to the smallest component, to the unit on the UI. Let's look at an illustration of this concept. So let's say we have a button to use to save our news article, and we click this button. The event is passed to the news article which this button is a part of. The news item passes that event to the containing article list, and then to the main screen that contains that composable, and then eventually to the view model that then saves this article to the database. So as you can see, all the events from the UI up to the database flow in one direction. On the other hand, in the view model, we're always observing the database, which could be done via a repository or a use case, or I don't know, depending on whatever architecture you're using. The idea is to be observing the database. The view model picks up this new state now that we've saved the article, and then it passes that state to the news screen. The news screen then passes this state to the article list, and then the article list passes it to the news item, and then to the save button. And then this is where we then reconstruct the save button, but this time, since the news article has been saved, then the new state is going to be this checked state. You will also notice that the state flows in only one direction. This architectural pattern helps us to minimize bugs in our state rendering. It ensures that the state exactly is how we modify it to be. And it relies on the fact that there is a single source of data, the single source of truth, which is the database in our case. We don't save the state in the UI, we don't get it from the UI, but we have a central place where we get the state from. This part is very important. You might have, your app might have an API component, like a cloud component where you make requests to the server. It is advisable to keep your database as close to the API state as possible. So for example, if you have liked an article, you save it in your database, and then you synchronize that with your cloud so that you then upload the cloud. If you go on another device and you unlike that article or unsave it, that should trigger something in your database that should update and let you know that this article is no more saved. And this is a very, very fundamental principle when you're implementing offline functionality for your app. So you kill two stones with one bird. No, you kill two birds with one stone, and you are able to adopt Jetpack Compose, and at the same time you are able to migrate your UI into a very reliable architecture and prepare yourself for potential offline functionality. Another important part of this design and this architecture is the reactive nature of everything. We observe changes to the data, we save something to the database, and then we observe that this data has changed. So we need something reactive to do this easily. In Android, there are different ways to achieve this. You can decide to use RxJava, which is one of the biggest reactive stream libraries in the Java ecosystem. You can also decide to use Kotlin, Flow, and coroutines. You could decide to use data binding, which has its own built-in observable system, or you could use live data. I personally want to recommend using live data because Google recommends it, and it's very easy to convert from live data into a Jetpack Compose state. Well, the specifics of this is left to your team, so you have that decision to make. It's also possible to integrate it with your existing RX Java code so you don't have to re-implement things. As mentioned earlier, Jetpack Compose is very interoperable with the view system, so it's recommended to take advantage of this interoperability while migrating gradually. We should take advantage of the interoperability from Compose View, from Compose View to Android View. There's a library called there's also a library called Jetpack Compose Theme Adapter, and this library is really useful. So the problem this library solves is that both Compose and View system have different ways of handling styles and themes. With the View system, we typically declare our resources in styles.xml, and then you maybe reference things in colors.xml, and then you register them in your manifest and things like that. But in the Compose world, things are a bit different. We just have a theme wrapper, and you just wrap it around the composable, and that's it. The children composable inherit the theme from the parent. So in order to be able to migrate, you definitely don't want to rewrite everything at once. So there's this adapter that helps you to transform your current style and theme requirements in the View system into Compose, and to incorporate it into your Jetpack Compose project or new code. It is very little change that you need to make. I think instead of using material preview, you use MDC preview, and all of the theming is transferred. I really recommend this approach. Testing is how we ensure good quality of our application and how we detect failures as quickly as possible. Typically in software engineering, we would love to get feedback as early as we can. We don't want to end up in a case where we ship the app and then we discover that on some devices the UI is doing somehow, or we didn't correctly integrate the Jetpack Compose with the traditional view system. So as a result of this requirement, it's recommended that as you update the app, you start adding tests for Jetpack Compose. Luckily, this has already been part of the thought process for Jetpack Compose team, and they've already built out a couple of libraries that we can use. One of them is the Android Compose test rule. This already comes with the Jetpack Compose library, and we can use it instead of the activity scenario rules. It enables us to do things that are Compose specific, like finding nodes in the UI hierarchy and confirming that this node contains this information. So we've talked a lot today, and we're about rounding up. But this time we want to have a look about what the future holds when it comes to Jetpack Compose and the opportunities that have opened up. We mentioned that Jetpack Compose is decoupled from the Android framework, and that opens up some real multi-platform opportunity. A few weeks ago, JetBrain launched a framework called JetBrain Compose, which is quite interesting because it's compose. And this JetBrain Compose is essentially used to build UIs for desktop that runs on Mac OS, on Windows, and on Linux. This opens up a real multi-platform and code sharing opportunity, and it leverages the power of Jetpack Compose to be able to deploy on different platforms. Remember, when I was talking, I said the Jetpack Compose is decoupled. So this is one of the major benefits of the decoupling. So the rendering of your Jetpack Compose code depends entirely on the system you're running on. And that's what makes it possible to be able to run on desktop. Imagine you have a business, you already have your business logic shared, you already have your app project modularized such that you're able to extract business logic and you can share it. Just like you share with your app module, you can then share with your desktop module. So basically this is increasing how much more decoupling we have and how much more we are able to have more cohesion and easy to share code across platforms. Server-side rendering has become increasingly popular these days. You will see that some apps render differently on some, if you're in a different location or something like that. A lot of people have invested time and effort in server-side rendering, and it has become really popular these days. I've seen a couple of experiments with Jetpack Compose on the topic of server-side rendering, and it makes things really easy. In fact, easier than the existing solutions that a lot of people have implemented today. There are a lot of talks about the concept of server-side rendering. In case you're not familiar with it yet, you could check those talks out. I've seen some people talk about some form of like transpiler that will convert Compose to Swift UI and Swift UI and vice versa. If this really happens, it's a big win for cross-functional teams, such that you just write your specs, your UI specs, and it gets compiled into or transpiled into Compose or Swift UI. This is going to be really massive if it happens. But again, these are all like futuristic or like potentials. It's not, I don't know if it's really in the works already or not. There are so many other possibilities that also will not talk about because of time, and also it's out of scope of this talk, but you should definitely check out the some resources that I've collected here. One of the resources is the code search resource. The code search resource, in case you don't know already, is where you can find nearly the entire code base for the Android operating system and the Android framework. There is a particular section that is for Jetpack Compose, and that is where you can see the development that is going on for Jetpack Compose. You can also check out the Pathway. It's a new series of courses that Google offers to master certain topics. So it goes from beginner with articles, with code labs, all the way to being proficient in that topic. Also check out the documentation and also for JetBrain. And with that, I've come to the end of my talk. Thank you very much for tuning in. Thank you for joining and listening. I hope you enjoyed it or learned a couple of things. Thank you and have a good day. Bye.